Hey there, everybody. Welcome back. We are going to take a look at systems of equations, solving those where substitution doesn't work that well because it generates a lot of fractions and no one likes working with fractions. This is 7.3 and we are solving by elimination. Elimination. Another name for this method is the addition method. It's got a couple names, okay? The idea here is make the coefficients for one variable equal but opposite. So they have the same value, but different signs. When you make so how do we do that? By multiplying the equations by the appropriate numbers, by appropriate values. When we have that, once we have that, we can add the two equations together. Which will eliminate the equal but opposite variable. And at this point, you have one equation with one variable. So now we are like the substitution method. Solve for the remaining variable. And plug your solution into an original equation. To solve for the other variable. And finally, check your solutions. All right. Let's get you cracking on a problem. Let's start off easy. 2x plus y equals 15. And 4x minus y equals, I don't know, let's go with 5. No, let's go with 9. That looks like a good answer. Y already has equal but opposite coefficients. So I don't need to make that happen in this problem. The way this works is we add them together and I get 2x plus 4x equals 6x. Y minus y is 0y and we don't need it anymore. 15 plus 9 is 24. So 6x equals 24. I divide by 6 and I get x equals 6. And I can go plug it into either equation. I'll plug it into this one. So 2 times 6 plus y equals 15. 12 plus y equals 15. We will subtract 12. And we get y equals 3. The solution is 6, 3. If I plug that into both equations, it will work. Or it should work. 12 plus 3 equals 15. and I plug it into the other one. 4 times 6 minus 9. Wait, minus 3. Ooh, this doesn't work. What did I do wrong? Four does not equal 9. Oh, what did I do? Add, divide, I get x equals 6. No, x does not equal 6. 24 divided by 6 is 4. Ha! All right, so I'll cross that out. Notice how I checked my work, and that didn't work. 24 minus 3 would have been 21 equals 9, and that's false. So checking my work showed me that I made a mistake. So I went back and found it, x equals 4. I'll plug that in. 2 times 4 plus y equals 15. 8 plus y equals 15. Subtract 8, and I get y equals 7. So the point is 4, 7. Now I'll check my work. 2 times 4 plus 7, does that equal 15? I get 8 plus 7 equals 15. That works. It should always work in the one you just solved to get the last part in. I solved in that one, so this should work. And then I check the other one. 4 times 4 minus 7, does that equal 9? I get 16 minus 7 equals 9, and that's true also. So 4, 7 is correct. And that's why you check your work, ladies and gentlemen, and people that don't identify in a binary system. That's why you check your work. Don't be a scrub like Jones. Like Professor Hefe. All right. Let's give you another one. Uh, 4x minus 3y equals negative 5. And 4x plus 4y equals 16. That's not 4y. That's 4y. Okay, so this was one I could probably do substitution without fractions on this equation. But we're doing the elimination method. So right now I see my x's have equal coefficients. If I want to make them opposite coefficients, I'm going to multiply one of them by -1. Let's multiply this equation by -1. If I do, I'll write it underneath here. I get negative 4x plus 3y equals 5. Now, when I add these two equations, 4x minus y, I just get 7y equals 21. And when I divide by 7, I get y equals 3. I'm going to go back and plug that into my initial equation before I multiplied by -1. Y is 3. I get 4x minus 9 equals -5. I will add 9 to both sides. I get 4x equals positive 4. Divide by 4 and I get x equals 1. So the solution is 1, 3. Our check. 4 times 1 minus 3 times 3. Does that equal -5? 4 minus 9 does equal -5. Then in our other equation, 4 times 1 plus 4 times 3, does that equal 16? 4 plus 12 does equal 16. So it works in both equations. All right, we'll continue on with our next problem to try. 5x plus 5y equals 40. 3x plus 4y equals 24. Now this one I could do with substitution by dividing by 5 and getting this down, but I'm not going to. I want to show you how it works. So when you have these and there's no obvious relation between coefficients like we had before, one way to do it is to pick a variable and use the other equation's coefficient. I'm going to pick the variables that has the lowest coefficients. X has a 5 and a 3. So what I'm going to do is this one has the 3. I'm going to take this and multiply this by the 3. And this one has a 5, and I'm going to take this and multiply this one by a 5. And that will end up with getting me a 15x on both of those. To make them opposite, I'm going to use a negative on one of the equations. So I'll use negative over here. So if I distribute that, I've got 15x plus 15y equals 120. And over here, you got to make sure you do everything. Negative 5 times 3 is negative 15x. Negative 5 times 4y is negative 20y. And negative 5 times 24 is negative 120. So when I line these up underneath each other, I can see when I add them up, I get negative 5y equals 0, which means y equals 0. Then I will take that and I will go and plug it back into one of the problems. 3x, I'm doing the one with the smaller coefficients right now, plus 4 times 0 equals 24. So 3x equals 24, x equals 8. I get 8, 0. I will check that in both equations. 5 times 8 plus 5 times 0, does that equal 40? 40 plus 0 does equal 40. 3 times 8 plus 4 times 0, does that equal 24? 24 plus 0 equals 24. So 8, 0 works in both of them. And let's just look at what I did. This has a 5. This has 3. So I took the 5 and put it over there. And I took the 3 and I multiplied by that. That way, it's like using the LCD of the coefficients. It's like finding the LCD of one of the coefficients. Or not LCD, but LCM, least common multiple. And then that's what I aim to get. So I multiply each one by the other one's value. And then I made one of them negative so that they would be opposite. Okay. Let's give you guys one to try. Uh, 2x minus y equals 10. And x plus 3y equals 33. And while we can do this by elimination, we're not going to. We're not going to do our substitution. We're not going to. Do this by elimination. Pick a variable to eliminate. All right. You got a couple good choices. The x's are actually closer in value. I only need to multiply one of these by 2. But I like that y is already negative. This y is positive. This y is negative. And it looks like if I just multiply this by 3, I have something that when I add them together, magic happens. So I add them together, I get 7x equals 63. I divide by 7 and I get x equals 9. Always plug it into the original equation, not the one, not that one, the original. 2 times 9 equal minus y equals 10. So 18 minus y equals 10. I will add y to both sides. Subtract 10. 8 equals y. And I put them together and I get 9, 8. Let's give that a gander, a check in our equations. 2 times 9 minus 8, does that equal 10? 18 minus 8 does equal 10. And if I do it in the other one, 9 plus 3 times 8, does that equal 33? 9 plus 24 does equal 33. That's the valid solution. All right, next example. 2x plus y equals 10. 4x plus 2y equals 2. This is kind of nice. The coefficients are multiples of each other. I'm going to multiply this one by -2 because y has a smaller coefficient. If I do, I get -4x minus 2y equals -20. And when I add them together, I did it to get rid of the y's, but it looks like I got rid of the x also. 0 equals -18, which is false. This system had no solution. And why don't we do x minus y equals 2. -2x plus 2y equals -4. I'll multiply this one by 2. I get 2x minus 2y equals 4. When I add them up, I get 0 equals 0 on both sides. 0 equals 0. This is true. So there's infinite solutions along the line. Along the line, x minus y equals 2. All right, that'll wrap up 7.3. We have applications of linear systems and systems of linear inequalities left. Guys, hang in there. Hang in there. You're almost done. Peace.